So pi is one of those numbers we could study for a decade, but for now, let's talk about what pi is in the most basic sense of the word. So we could observe a circle and we can measure some things with really basic tools with a rope and a stick. And we could say, I can measure the circumference. That is basically synonymous with the perimeter of the circle. I could put a rope around the circle. And then I could take a stick and I could say, what is the difference between the rope? Put a little knot at the end so you know it's a rope. It's a frayed knot. And then what is the difference between the rope, which goes around the circle, and the stick, which tells me the diameter of the circle? Let's say this is the circumference. This is the diameter. How are these related? And we find out that the circumference over the diameter gives us this special number pi. Pi is an irrational number. That means it goes on forever and ever and ever. But it is approximately 3.14, or as engineers sometimes say, it's 22 sevenths. This is an approximation as well. This is not pi. It's close. It's 3.14, and then it gets off after in the thousandths place. That's close, but it's not exactly. Okay, so this is what pi is. It's just a number, but it describes the ratio between the circumference of a circle and its diameter. That is what pi is. So we can rearrange this formula for pi to figure out what our circumference is. So we've got this idea of circumference and diameter being somewhat related, and they're related, well, not somewhat related, they are exactly related by this number. This ratio provides a number, and that number is pi. We can rearrange this formula to figure out the circumference of a circle, given that we know pi and we know the diameter. The circumference is pi times diameter. We can also know that diameter is simply 2 times our radius, so we can manipulate this expression even further to say that the circumference is 2 pi times the radius, because diameter is equal to 2 radii. Okay, so this brings us to an interesting question. Let me provide you with a circle. I'm going to say this has a radius of 4. What is the circumference of the circle? So if you were a little ant, you're going to walk around the whole edge of the circle. How far would you walk? So you would walk exactly 2 pi times 4, which is 8 pi units of length. 8 pi is my circumference. This is an exact answer. This is exact, where if I said 8 times 3.14, if I did this math, this would be an approximation. Hopefully that is clear to you. So this is an approximation because 3.14 is not perfectly pi. It is close. So this is our approximation. Okay, the next thing we need to talk about is, well, I can find a whole circumference, and I can do that in many different, for many different circles. And what if I only wanted to find a portion of the circumference? Well, a portion of the circumference has a special name, so we're going to call it arc length. And that would be on this fruit that I found in Mathland. That would be the length of the rind for one segment of this fruit. So this segment has a vertex angle of 72 degrees. And I'm going to ask you to find, what is this arc length? So let's do that together. So first I would say, let's find the circumference for the whole circle. This circle has a radius of 3 inches. So we have 2 pi times r, which is 3. So the circumference of the whole circle is 6 pi. And how many 72s are there in 360? We can do this in 2 ways. We can say 72 divided by 360, or we can visualize how many it would be. So, or if you already know it, this is the same ratio as 1/5. So I've used up 1/5 of the circle with this angle. So it makes sense logically that my arc length is going to be 1/5 of the circumference. So my circumference is 6 pi times 1/5 is equal to 6 pi over 5, and this is units. This is just a length unit. It's a linear unit. It's not a square unit. Okay, that pretty well covers pi, circumference, and arc length. Let's move on and let's talk about the area of a circle and sector area. If you want a more complete explanation for how we derive the area of a circle, you can look at that video, which I've posted earlier. But for now, let's just talk about the area of a circle. That is pi r squared, right? Pi r squared, pi r squared, pi r squared, pi r squared, pi r squared. I'd like that to be ingrained in your memory forever. Pi r squared. You will see that on all over the place for the rest of your life. So you need to know the area of a circle is pi r squared. So let's look at this piece of fruit, another piece of fruit that I found in Mathland. And we're just going to say this time, instead of the rind being really valuable, so I want to calculate how much rind I have, the fruit of this, like the meat of this fruit, is the valuable part. So we're going to see how much tasty fruit I can get from this this sector here. So first of all, let's figure out the area of this cross section. So I'm told I have a radius of 2 inches. So the area of this particular cross section is pi times 2 squared. So our answer is going to be 4 pi units squared. We actually know this. We know it's 4 pi inches squared. So the area of our piece of fruit here, of our cross section of a piece of fruit, is 4 pi inches squared. What about just one segment? Well, we're told we have a vertex angle here of 60 degrees, which makes sense. I've got 6 pieces of fruit here, or 6 segments in this one piece of fruit. And so 360 divided by 6 is 60. So how many segments are in this piece of fruit? Well, there are 6. So for a sector area, I just divide this by 6. So our sector area is going to be 4 pi inches squared divided by 6, which is 2/3 inches squared. Awesome. Have a great night.